Okay, today we're going to do what's called combination circuits. So it's a combination of series and parallel. Now if we look at our notes for a second first, again, we're going to have series and parallel combined in one circuit. And there's a certain systematic way that you do these problems. So I just kind of typed out some steps that we're going to follow when we do we're going to do one of the homework problems together, D1 together, which is the hardest one. So it says first, calculate the equivalent resistance. Then you're going to put them all together. So basically what we're going to do is we're first going to find RT. So those of you who don't like to do schematic diagrams because you say, oh, I can do it in my head, you have to do a schematic diagram here. So let's look. We're going to do this problem here. Okay? So, the first thing that we're going to do is we're going to draw an equivalent resistance that we're going to get this to just being one resistor. So what I'm going to do first is I'm just going to draw this. I'm going to redraw it on my paper, because the diagrams are the only way to do this. So this is RA, and this is 5 ohms. This is RB, this is 7. This is RC, which is 4. This is 14 volts. RF is 2. RD is 4. And RE is 4. Okay. So, I know the total voltage is 14 volts. And what I want to find is, the first thing in doing these types of problems, well, at least to help you to understand it, is I want to find RT. Now, if you look at all these resistors, are all of these in series? Can I just add them? No. Are all of them in parallel? No. How do you know what's going on in a circuit? What you have to do is you have to look at the current. So remember, the current is like the water flowing through a pipe. Okay? So coming out of this battery, I'm going to have here my total current I. Now what happens at this point? Isn't some of the current going to go here and someone is going to go here? Right? So that means that this branch and this branch are in parallel with one another because it's going to split. Then it comes all back together. So now I have my total again flowing through here. But what happens here? Does it split again here and here? So that means this and this are in parallel with one another. And then it comes together again. So it's kind of like when you're doing circuits, when you want to simplify to get an equivalent resistor, it's like order of operations in math. You just have to practice till you know what goes first. So what I'm going to do first is, do you see how the current that goes through here, what flows through here and what flows through here, are those the same? Yes. It's like water flowing through a pipe. If I had water flowing through this pipe, what goes through here is the same what's going through here? Is there only one path for it to go? So because there's only one path, those two are in series. So what I can do right now is, because RA and RB are in series, I can add those two first. So I can say RAB is equal to RA plus RB, right? So if I do that, I'm going to say RAB is equal to 5 ohms plus 7 ohms is 12 ohms. So RAB is equal to 12 ohms. If I redrew this, okay, now before if I redrew that part, instead of RA and B, what I can do is I can have RAB, and now I see RAB is in parallel with RC. So RAB, I replaced these two in series, is now with that. So I added those in series. So this is 12 ohms. Does everyone see what I did? Now for the rest of it, everything else stayed the same. I didn't change it. This is RE, RD, and RF. All right. Now, these two are in parallel. How do I add resistors in parallel? I do 1 over. So I'm going to say 1 over R ABC is equal to 1 over RAB plus 1 over RC, because the current divides. So that's how I know these two are in parallel. So 1 over RABC is equal to 1/12 plus RC was 1/4. This is where doing fractions kind of comes in handy. So for me, when I was in school, we usually had numbers that were whole numbers like this that was easy to find a common denominator. So the common denominator is 12. So 1/12 plus 3/12 is 4/12. So 1 over R ABC, 4/12 reduces to what? 1/3. And then if I cross multiply, RABC is equal to 3 ohms. While I'm doing this, I'm going to add these two because RD and RE are in parallel as well. So what I'm going to do is I'm going to add those together. And in parallel, I'm going to say 1 over RDE is 1 over RD plus 1 over RE. So they're the same. Are they the same? No. Oh yeah, they're both 4. So 1/4 plus 1/4 is equal to 2/4, which reduces to 1/2. So 1 over RDE is 1/2. And then when I cross multiply, I get what? I get RDE is equal to 2 ohms. So this branch and this branch were in parallel, so I used the rule for parallel for adding. These two were in parallel, so again I used the rule for equivalent resistance for parallel. Does that make sense? Okay, now I'm going to draw my circuit now. So now, instead of RA and B in parallel with RC, I found my equivalent resistor. I'm going to call RABC. Then I'm going to replace D and E with my equivalent resistor I had called RDE. And then I didn't touch RF. So these are called intermediate schematic diagrams because our goal is to just get one equivalent resistor. Does that make sense? Now, what do I have here? I have 3 resistors. There's current coming out of this battery. Now, the total current's going through here, through here, through here. So there's only one path for it to take, which means the resistors are in series. So now, if I want to find RT, RT is equal to RABC plus RDE plus RF. So RT is going to be equal to 3 ohms plus 2 ohms, and then RF is 2 ohms. So 3 and 2 is 5 and 2 is 7. So RT is equal to 7 ohms. Now this question says calculate the current and potential difference across each resistor. So I'm going to go back to my original picture And I'm going to find V, I, and R for every single one of these. I already have R, but I'm going to find V and I. Now, I found RT. I know that VT is equal to what? 14 volts, which means I can find what? IT. So I'm going to use Ohm's law. V is equal to IR. And I'm going to apply it for the whole circuit. So I'm going to say VT is IT times RT. So IT is equal to VT over RT, which is 14 volts over 7 ohms. So the total current coming out of the battery is 2 amps. But they want me to find the current and the voltage drop across every single resistor in the original picture. So here's my final picture. My final picture is one resistor called RT, which I found is 7 ohms, right? And I know my total voltage, that's 14. So the way that you do parallel series circuit combinations is you keep simplifying the resistors, like order of operation in math, till you have one equivalent resistor. Once I find the total current, now I'm going to use these intermediate schematic diagrams to go backwards. And what I do is I do my work right on there. So let me show you. So I found the total current coming through here is 2 amps, right? Now I'm going to say, these 3 resistors, what were their relationship? They're in series. Then I'm going to say to myself, what is the same in series? Well, if I'm not sure, I'm going to look at my chart. What's the same in series is current. The total current is the same through each branch. So, if this is 2 amps, that means this is 2 amps, that means this is 2 amps, and that means this is 2 amps. Because I'm saying, what's the same in series? Does everyone follow how I got that? Because this is 2 amps, and I know in series, the current is the same throughout. Now, I'm going to apply Ohm's law. So I'm going to say here, V is equal to IR. DE, this R was 2. So if I have R and I have I, can I find V? Yes. So V is equal to 2 times 2. So the voltage drop here, this is 4 volts. This one is also 2. So 2 times 2 is 4 volts. So now I found VF is 4 volts. And the voltage drop across here, V is equal to IR. So it's 2 times 3. This is 6 volts. Now, before I go on, this is the great thing about circuits. I want to check my work. I want to know, am I doing this right? Because this is a complicated problem. What's the relationship between voltage and series? If you're not sure, you look at your chart. In series, the voltages add up to the source. So I can just do this in my head. I'm going to check before I go on. I know that the battery is 14 volts. So that means that the voltage drop across these 3 resistors has to add up to 14. So 6 and 4 is what? 10. And 4 is 14. So you see how these 3 add up to 14? So in my head, I'm checking my work. All right? In my head, I'm checking my work. All right. Now we're going to go back to the diagram before. All right. This equivalent resistor, how did I find RDE? I added RD and RE in parallel. I found the voltage across this one was 4 volts. The current was 2, and the resistance was 2. Now, I want to go back to this picture. What is the same? What is the same in parallel? These are in parallel. What is the same? I'm always going to ask myself, what's the same? So when I say same, I mean it's equal throughout. So now I'm going to go back and look. In parallel, the voltage is the same. So that means this 4 volts, that means this is 4 volts, and this is 4 volts. Okay? Because these are in parallel, and the voltage is the same. If this is 4 volts, this is 4 volts, and this is 4 volts. Okay? Now, if I have R and I have V, can I find I? Yes. So this was 4 ohms, and this was 4 ohms. So I is V over R, so 4 divided by 4 is 1. So the current through this resistor is 1 amp, and the current through this resistor is 1 amp. Now, I could have done that one kind of common sense. I know the total current going through this wire was 2, and because these resistors were the same, they would split evenly, 1 and 1, right? All right, let's go back to this diagram. How did I add these 2 resistors? I added these 2 resistors, so in order to get this RABC, how did I add these? These 2 were in what? Parallel. What's the same in parallel? V. So if this is 6 volts, that means this is 6 volts and this is 6 volts. The only way to actually do these, that if you understand, is to use these intermediate schematic diagrams. So all of you guys who were turning your homework in and you're like, oh, I didn't do the schematics. I said you have to do schematics. This is the way, the only way for you to understand circuits. This is the only way. And it takes practice. Just like when you first learn to do order and operations in math, it takes practice. So if this is 6 volts, if I have V and if I have R and V, can I find I? So the current here, I, is going to be V over R. So 6 divided by 12 is 0.5. So the current going through here is 0.5. And then I'm going to do the same thing here, and I'm going to say I is V over R. So 6 volts divided by, what's RC? RC is 4. 6 divided by 4 is 3/2, which is 1.5. Now let me check the work. Remember, the total current coming through this wire is 2 amps. Is 0.5 plus 1.5 2? Yes. Right? So now I found this I here is 1.5 amps. All right? So the only thing I haven't found is the first diagram. I need to find the current and voltage across those 2 resistors, because I did for everything else. All right. So in order to get this equivalent resistor, what did I do? I added these 2 in what? Series. What's the same in series? I. So if this I here is 0.5 amps, that means the current here, I here is 0.5, and I here is 0.5. And then I can use Ohm's law and say V is equal to IR. So for this one, 7 times 0.5 is 3.5 volts. And then here, 5.5 times 5 is 2.5 volts. So that's the voltage drop across each one of these. Now this is the hardest problem in the homework in the chapter. Now, well, you might think it's a lot of work, but this is the way to do it that you actually understand it. This is not memorization. And we're going to have a combination on our test. It's not going to be this hard, but we're going to practice and practice doing these. But this is important because honestly, if you take physics in college, they're going to have ones harder than this, okay? And I'm not talking about circuits courses. I'm talking about just physics, because when you take circuits courses, they get much, much more complicated. there's a systematic way to solve this problem. So I'm just going to do a quick recap. You draw your basic picture. You're going to start simplifying stuff. So you're going to look at the current and the wire and say, what's the relationship? How can I simplify? So in this problem, the first thing we did was these two were in series. I couldn't just add all these in parallel because first I had to add these two in series. That's kind of like your order of operation. So I combined these two resistors. Then this combined resistor and this one, these were in parallel. So then I combined these in parallel. These two were in parallel, so I combined those in parallel. And then these three were in series, so then I added these in series to get one equivalent resistance. Once I had one equivalent resistance, I used Ohm's law, and I found the total current. Then I said to myself, what's the same? Because these three were in series to get this, okay? What's the same in series is the current. So if this is 2 amps, this was 2 amps, this was 2 amps, and this was 2 amps. Then I used Ohm's law. V is equal to IR to find the voltage drop across this resistor, and this resistor. Then, how did I get this? I got this by adding these two in parallel. So then I said to myself, what's the same in parallel? The voltage. So if this was 4 volts, this was 4 volt, this was 4 volt, then I can find I, because Ohm's law has 3 variables, V, I, and R. So once you have 2, you can find a third. Then I did the same thing here. This was 6 volts, so I went back here and said this is 6 volts and this is 6 volts because these two were in parallel, so the voltage is the same. So then I found the current. So what you do is you start with one diagram, you combine. Once you get here, then you use these intermediate schematic diagrams to solve. You cannot do this without these pictures, okay?